Imagine landing on an alien world where no one from your nation has ever stepped foot, a place so desolate and cold that even machines can barely survive. Now imagine being the first robot your country has ever sent there, and you're expected to find answers to one of the greatest mysteries in science. Is there life on Mars? That's not a science fiction setup, it's real. And China is living it right now. The world was focused on NASA's Perseverance rover and its little helicopter buddy flying around the dusty Martian skies. But quietly, half a planet away on Mars, another machine was rolling over ancient terrain with a mission just as bold, and maybe, just maybe, it got closer to solving the riddle of Martian life than anyone else. Its name is Zhurong. It doesn't get the fanfare of Perseverance, nor the sleek design of Ingenuity. It's not nuclear-powered. It doesn't have a sample return plan. But Zhurong, China's first-ever Mars rover, is proving that determination, grit and good engineering can open secrets long buried beneath Martian sand. Zhurong launched in July 2020, hitching a ride on the Tianwen-1 spacecraft, which translates beautifully to heavenly questions. That name alone tells you what this mission was about, not just science and exploration but something deeper, something spiritual. China wasn't just launching a probe. They were entering the elite club of nations who had dared to touch another planet. Up until then, only 3 had succeeded: the Soviet Union, the United States, and briefly and tragically, the British. The Soviets were first. Mars 3 in 1971 made it to the surface and even sent back a single image, grainy, gray, barely decipherable, before it went silent forever, possibly killed by one of Mars's infamous dust storms. Then came the Beagle 2 from the UK in 2004. It was a small, charming lander with big hopes. But something went wrong during deployment and it never phoned home. It wasn't until years later that NASA's orbiters spotted it, sitting quietly on the surface with its solar panels only half open, as if frozen mid-sentence. And then, of course, there's NASA, the masters of Martian exploration. Viking, Pathfinder, Spirit, Opportunity, Curiosity, Perseverance. Rovers, landers, helicopters. The list goes on. So when China decided to leap straight from moon missions to a fully robotic Mars landing, with a rover no less, it wasn't just ambitious. It was audacious. And against all odds they nailed it. Their choice of landing site wasn't random. Zhurong touched down in a region called Utopia Planitia, a vast, flat basin in Mars's northern hemisphere. To the untrained eye it might look dull, featureless even. But this place holds secrets. Deep, ancient secrets. Long ago, billions of years in the past, this might have been the floor of a Martian ocean. Scientists believe that Utopia Planitia once held water. A lot of it. Enough to cover the region in an ocean larger than the Arctic Sea. And where there's water, there's always the possibility, however faint, of life. Zhurong's mission was clear. Explore, examine, and see what Mars might be hiding beneath the dust. Now here's where things get fascinating. Utopia Planitia wasn't just some convenient landing zone. It's the same region where NASA's Viking 2 lander touched down back in 1976. That mission, though rarely talked about today, was monumental. Not just because it was one of the first to make it to Mars, but because Viking may have discovered something strange. You won't find this story in most textbooks. Officially, Viking 2 didn't find life. But unofficially? Let's just say some scientists still lose sleep over what happened. Here's what went down. Viking 2 conducted an experiment. It scooped up Martian soil and added a special mix of water and nutrients to see if anything alive, would consume the nutrients and release gas as a byproduct. If there were microbes in the soil, the theory went they'd eat the food and exhale something like CO2. And wouldn't you know it? That's exactly what happened. The soil fizzed. It produced gas. Life on Mars? Confirmed? Not so fast. The second part of the experiment added more nutrient-rich water to the same sample. The thinking was if bacteria were alive and well, they'd now be thriving. They'd be multiplying. So with more food, they should release more gas. But they didn't. In fact, they released less. NASA eventually concluded that it wasn't life after all. Maybe just some weird chemistry. But others weren't so sure. What if the microbes were real? And what if, in our enthusiasm to feed them, we accidentally drown them? It's a haunting thought. The first Earthlings to find Martian life, and kill it with kindness. Now fast forward nearly half a century. Zhurong is rolling across the very same Martian plain. The same sand. The same rocks. And potentially the same secrets. You'd think a modern rover would be equipped with all the latest tech, but Zhurong is actually fairly simple by comparison. It's solar-powered, no nuclear batteries like NASA's rovers. It weighs about 240 kilograms, which is modest, just about a third of Perseverance's mass. And its landing system? No high-tech sky crane, no bouncy balls. Just old-school engineering, a heat shield, a parachute, retro rockets, and a set of spring-loaded legs. But don't let the simplicity fool you. That system worked perfectly. Zhurong survived Mars's notoriously thin atmosphere, slowed down with a parachute that barely had any air to grip, and then used a rocket-powered descent module to ease gently onto the surface. The final moments were taken care of by shock absorbers, just like Viking 2 before it. It was elegant, efficient, and effective. Once on the ground, the rover got to work. It deployed a ramp from the lander, extended its solar panels like wings, and then slowly rolled off into Martian history. It was only the second time in history that a new space agency had successfully landed a rover on Mars and had it operate successfully. Zhurong was built with a mission duration of 90 days. That might not sound like much, but on Mars time is borrowed. Dust storms can block out sunlight for weeks. Temperatures can plunge to -100 degrees Celsius overnight. Everything is out to kill a machine like this. And yet, against the odds, Zhurong kept going, day after day, week after week. Its scientific payload was compact but powerful. First, a set of high-resolution cameras to take sweeping panoramic images and detailed pictures of rocks and soil. These cameras could also be used to navigate and scout potential paths ahead. Second, a ground-penetrating radar system. This is where things get interesting. With radar, Zhurong could look beneath the surface of Mars, something Perseverance doesn't have. It could scan several meters underground to see what was buried beneath the topsoil. Sediment layers? Maybe even signs of ancient lakes or hydrothermal activity. And third, a laser-induced breakdown spectroscope, basically a laser zapper. Zhurong could fire at rocks, vaporize a tiny section, and then analyze the resulting plasma to figure out the rock's chemical composition. It's a non-invasive way to dig into Mars's history, one spark at a time. So what did it find? That's where things get a little mysterious. Imagine dust storms so vast they blanket entire continents. Winds that howl through valleys of red rock and time-worn stone, burying the secrets of a once-living world beneath layers of rust and silence. And now, imagine something breaking through that silence. Not a human, not a creature, but a robot built thousands of miles away, crawling across a forgotten ocean floor. That's exactly where China's Mars rover Zhurong found itself, alone, determined, and on the verge of revealing something that could change everything we thought we knew about the red planet. While most people were busy watching Perseverance and its helicopter dance across the cratered surface of Jezero, Zhurong was digging deeper, literally. The third instrument in its scientific arsenal wasn't as flashy as a laser or camera, but it was arguably the most important, a ground-penetrating radar. And this one simple tool may have cracked open a Martian mystery buried millions, maybe billions, of years below the surface. It started slowly. Beneath the dusty surface of the Utopia Planitia region, the radar picked up strange patterns, ripples in the underground like whispers from the past. Over just 1 mile of travel, the radar mapped out 76 distinct underground layers, hidden between 10 and 35 meters below the surface. These weren't flat, dead layers either. Each one was tilted, sloping gently northward. To a geologist's eye, that detail alone speaks volumes. This wasn't just ancient rock, it was a coastline. An old shoreline shaped by flowing water, carved slowly and steadily by tides, erosion, and time. It's hard to overstate what a discovery like that means. Because you don't get a shoreline without an ocean. And you don't get layers like that without water flowing again and again, season after season for tens of millions of years. And where there's long-standing water on a planetary scale, there's a chance, however slim, for life to emerge. Up until now, the prevailing wisdom had been that Mars lost its water over 3 billion years ago. But the underground layers Zhurong uncovered were telling a different story. A flood had raged across that landscape about 3 billion years ago. Yes, but more than that, the data showed another massive rush of water sweeping across the same region around 1.6 billion years ago. That's far more recent than anyone expected. Suddenly, the timeline was being rewritten. Mars wasn't dry and dead for as long as we thought. Instead, it had water, possibly oceans, long enough for life to appear and potentially evolve. At a time when Earth was teeming with early microbial life, there may have been puddles, pools, and even flowing rivers on Mars. The kind of environments that, on Earth, are teeming with bacteria. But Zhurong wasn't done yet. It rolled on, driving quietly across the dusty floor of Utopia Planitia, its solar panels soaking up sunlight while the Martian wind tried its best to bury it alive. It found a line of long, low sand dunes stretching 30 meters across, barely a meter high. They were small enough that the rover could just climb right over them, and that's exactly what it did. What it discovered on top was weird. The dunes weren't just piles of sand. They were crusted over with a hard, salty outer layer, almost like cement. And not just a thin layer either. The crust was nearly 8 centimeters thick, running deep into the dunes, solid and sharp, crackling under the wheels. That shouldn't exist on Mars. At least not without water. See, the Martian wind is unrelenting. Any crust formed slowly over time would have been obliterated by sandstorms long ago. Which means that whatever created this salty armor, did so quickly, and probably recently. The leading theory? Liquid water. Somehow, liquid soaked the tops of those dunes, then evaporated rapidly, leaving behind a residue of salt and minerals, baking it into a brittle shell. But where would that water come from? The answer might lie in the sky. Scientists now believe that snow may fall on Mars during certain climate cycles. Specifically, they think water vapor escapes from the ice caps at the North Pole, drifts down across the plains and falls as snow. That snow then interacts with salty minerals left behind from ancient oceans. Salt lowers the melting point of ice, meaning even in the frigid cold of Mars, some of that snow could briefly melt, forming briny puddles that soak into the sand before flashing into vapor again. And the strangest part? This process may have happened just 400,000 years ago. That's not ancient history. That's yesterday on the scale of planetary time. While early humans were inventing fire and tools here on Earth, Mars was experiencing snowfall. It's a haunting overlap, one planet blooming with life, the other holding on to its last drops of moisture, like a ghost of its former self. But what's causing that snow in the first place? Why would Mars, frozen, desolate Mars, suddenly warm up enough for snow to fall and melt? The most likely answer comes down to orbital mechanics. Just like Earth-Mars wobbles. It shifts. Its orbit and tilt change over long, slow cycles. On Earth, we call these changes Milankovitch cycles. They're the reason ice ages happen. There are 3 key cycles involved. Eccentricity, which changes how oval-shaped the planet's orbit is, axial tilt, which alters the intensity of seasons, and precession, which causes the planet to wobble like a spinning top, shifting the timing of those seasons. We know these patterns influence Earth's climate in dramatic ways. It's reasonable to assume that Mars undergoes something similar. And when the conditions are just right, the North Pole warms, water vapor escapes, and snow falls again. Not every year. Not even every millennium. But maybe once every few 100,000, or million years, Mars gets a wet season. And during one of those wet seasons, life might have flickered into existence. Now here's where the story gets a little tragic. Because there's a theory, more speculation than science but chilling nonetheless, that we might have already found that life. Back in 1976, NASA's Viking landers scooped up soil, added nutrient-rich water, and detected what appeared to be biological activity. CO2 gas bubbled out as if something in the soil was alive and breathing. But then they added more water, and the bubbling stopped. NASA concluded it wasn't life after all. But what if they were wrong? What if Martian microbes weren't built to handle all that water? What if they were adapted to dry, barely hydrated conditions? It's entirely possible we found alien life, and drowned it. And now, nearly 50 years later, Zhurong may have discovered the layered remnants of that same system. One that allowed life to rise slowly over billions of years, only to vanish into dust and salt. It's hard not to feel the weight of that. The Chinese rover was only meant to last 90 days. Solar power on Mars isn't reliable. Dust chokes everything eventually. But Zhurong didn't quit. It powered forward for 358 days, almost a full Earth year, scanning, digging, scanning again. Until one day in May 2022, it powered down to wait out a dust storm. Just a temporary nap, they hoped. But the Martian wind is cruel. It hasn't woken up since. Still, this isn't the end. Not for China. Not for Mars. In 2028, a new generation of Chinese robots will launch, not just to explore but to return. For the first time in human history, real physical samples of Martian soil will be scooped up and launched back to Earth. And when they arrive, it won't just be dust and dirt in those canisters. It'll be the first whispers of alien biology, or the final confirmation that Mars has always been silent. And maybe this time we'll understand what we're looking at. Maybe this time we won't kill it. But let's be honest, we probably will.